Hey there, welcome to a video discussing reasons we can use for our geometric proofs. So this document has a lot of different reasons or theorems, as they call them, or postulates, but let's just focus on those that are relevant to our test. So first thing I want to focus on is the reflexive property. Reflexive property is when something equals itself. So if you had, say, like segment AB is congruent to segment AB, or angle A is congruent to angle A, you'd use this, the reflexive property. Vertical angles, when vertical angles are congruent, that looks like this. So say, for example, that's like A, B, C, and D, B, E. So angle ABC, sorry for messy handwriting, it's congruent to angle DC, DBE. So we have that. Um, Some of these other ones are not too relevant, but substitution, we're not going to really be dealing with that. But there's something called transitive property, but we'll worry about that later. But those are two big ones, reflexive and vertical angles you want to be aware of. Um, of course, all right angles are congruent if you do encounter that. The parallel lines are the kind of the big ones here. Same side interior angles. Well, actually, we don't really, no, we're not going to have that on our test. But alternate interior angles, you do want to know that if two lines are parallel, the alternate interior angles are congruent, or if two lines are parallel, the corresponding angles are congruent, or vice versa. If two lines form or the corresponding angles are congruent, then the lines are parallel. Or if the alternate interior angles are congruent, then the lines are parallel. Um, so we have those. So those are important to pay attention to. You don't have to say the converse, but you could just say, again, two lines are parallel. The alternate triangles are congruent, or alternate triangles are congruent for parallel lines, or um, corresponding angles are congruent for parallel lines. Um, and then I want to point to the similarity theorems. Um, and I'll share this link, but if you have two pairs of, yeah, so right here, the AA similarity. So if you have two pairs of angles that are congruent, then we could say, hold on, I'm jumping around a little bit here. My apologies. Yes. Um, if you have two corresponding angles that are equal, two pairs of corresponding angles are equal, that's AA similarity. If three corresponding sides are in the same ratio, that's side proportionality. And then a side angle side, if you know two sides are proportional, angle in between them are the same, that's side angle side proportionality. Sorry, side angle side similarity. So yeah, so here for angle similarity, if let's say A equals E, B equals G, then you can use A similarity. For side angle side similarity, say you happen to know that the ratio of AB to DE, AB to DE, is the same as the ratio of AC to DF. And then, of course, angle A and angle D are equal to each other. That's side angle side similarity. Then side side, all three sides are proportional, PQ to DE, PR to EF, and QR to DF, for example. They have side similarity. And then lastly, do check your notes. I don't remember exactly where in the notes this would be, but there's another one called corresponding angles of similar triangles are congruent, or corresponding sides of similar triangles are proportional. So once we've established that we have similar triangles, like say up here, then we could, say you're told that B is the same as G, A is the same as E, and then these are similar. Then of course, C is also the same as F. And that's using that right there. Or AB to EG is the same as the ratio of AC to EF. Then of course we're using that one right there, CSSTP. So that's what's going on. And yeah, that's the proofs that you need, or sorry, the theorems or the reasons you need to know for our proofs.